Welcome to Atom Block Studios. Today I'd like to show you a video that has both a question and answer that can be taken care of in under 10 seconds, easily. But that isn't the point of these videos. I want a video like this to really serve the astrophotography community by explaining things in such a way that not only does it solve this particular issue, which a lot of people have and don't understand what's going on, but you can use this more expansive demonstration and instruction to solve other problems that are not necessarily even related to this. That's what sets apart the videos that I make at Atom Block Studios. I hope you'll consider becoming a member of Atom Block Studios if you like the kind of information that I'm about to explain here. So this particular problem came about with an email that I received concerning a particular image. The image here on the screen is of M101, very popular target to take a picture of. And as part of the workflow in processing this data, the individual who asked the question came up with an error. PCC said it couldn't find matched stars. It couldn't detect stars, is kind of what the error says. And I'll show you that error in just a moment. So now I will tell you in these 10 seconds what the problem is, what the answer is, but then I'll show you some very powerful things that, if you haven't seen them in PixInsight, this will be a great lesson to illustrate many things, both small and much larger, to consider. So the issue is that when you use photometric color calibration, there are two steps that it does. First, it needs to align your image with a catalog so that it knows the coordinates of every star and every pixel, basically, in your image. That's called a plate solution. The plate solution, it's called a world coordinate system, is generated by looking at an extensive catalog that has, millions and millions and millions of stars. So that's here under the plate solving parameters. It doesn't use the same catalog as what is the second step. The second step is to use a catalog that does the photometry. This is what actually compares colors of stars. You see, the one that does the plate solving, though it has technically even many more stars, it doesn't have any color information. It's just good in this particular usage for registering the images, for doing that plate solution. The photometry part, where you're actually looking at the color of stars, that requires a special set of catalogs. In this case, it's the APASS set of catalogs. And now I can show you the problem. The problem is that the APASS catalog has a couple of different versions, older versions, newer versions, and they have different degrees of coverage of the sky. You see, it may be that the object you're looking at has nothing to do with, the popularity of the object or anything like that. It could be in a region of sky which is just not covered by the catalog. And it's unfortunate, I think this is an unfortunate thing, a little bit of a critique. The error that PixInsight generates when it shows you the error, it kind of makes it sound like it's your fault. It makes it seem like, well, there's something wrong with your data. But that's not the case. In this case, the problem is that the catalog itself that's being examined is incomplete. And I can show you both how to fix it. I can show you what it looks like. I can show you all kinds of cool things. Let's go do it. So here's what it looks like. The normal way of using photometric color calibration is we grab, if it's available, the information from the image itself, which I've done here. And these are the correct values, so I don't have to do anything else other than basically press the little square button down here at the bottom. I'm not worried about the normalization. If you want to see the image look better and all of that, we can unlink here, and you can see the image looks fine. There are plenty of stars. The gentleman who created this data did a great job. There's really nothing wrong with this field, with this image. It should just work. But let's see if that's true. Now, one of the things that you should see here is that I have everything set to automatic. And one of the things that I've instructed people to do as part of my tutorials, and I think in general the word has got around, is that PixInsight makes available local catalogs. You no longer have to require on going out to the internet, the servers, which may or may not be operational when you go ask, to show me matching stars. So you can download the catalogs, have them locally on your machine, and you never have problem accessing them. So that's what's taking place here, and that is basically the default that I am working with. one of the things that I explain in FastTrack Training is this is the first thing to do, is download those catalogs so that we're all working on the same page, basically, with regards to getting the right answers for exactly this express reason that I'm going to show. So here we go. We have the defaults. I'm using the local catalogs. I'm going to press the button. And the first thing that PCC does, it goes out and it tries to do the plate solution. It did it. It's so fast. It's already done. You could see some of the transformation coordinates. It figured it out. And now it's got to do the second part, which again, it's doing very quickly here. And you'll see a red couple of lines there. It's going to do for each of the channels here in the colors. But those, as you'll see in a moment, those errors are the ones that are of consequence here. So here it is. Here's the error. It says, failure to process the image, could not locate any stars in the image. That sentence right there, it's not correct. What it couldn't do is it couldn't locate any stars in the star catalog. Which image are you talking about? So that is actually what's going on here. Now that may be true if we look at some of the data here, and maybe we could infer that it was talking about the catalog. But it really should say here, failure to do something because it couldn't identify any stars. Now let me prove to you why that, what is going on here? What do you mean it couldn't find any stars? Well, when you use the automatic catalog and you set this up, there are actually two catalogs that are in play, local catalogs for the photometry. I'm going to now turn this off, and if you hit the down arrow, you'll see that these are the two that it's going to choose first. If you have a local catalog, and you say, press the button there for automatic catalog, it's going to go to the local one first. And then, of course, if there's a problem, it'll go out to the one on the internet out in the cloud there somewhere. So the APASS 9 here is my local catalog. It has that XPSD designation, and so is the APASS 10. Now the APASS 10 is the newest one, so that when you do the automatic catalog, the one that it's going to choose automatically is the APASS 10. You'll see why in a minute that could be problematic. Now the one that, when you go out on the internet, the one that it's using is the APASS 9. And we also have the APASS 9 here. It's available to us, but it is not the default, as many people have it set, to do the automatic catalog. So I'm going to change it. I'm going to force it now. Everything else is the same. The only thing I'm changing is the fact that we're going to now be using the APASS 9 photometry catalog. So here we go. I'm just going to press the button again, and let's see what happens this time. We can see it's doing the plate solution once again, no problem. And now we have photometry taking place. Now it's actually measuring. You can see there, catalog APASS 9. It's finding the ones that are the stars that are matching in the catalog compared to the data in place here, measuring the colors, and then it'll come up with the cool graphs that you expect to see. So here we are. It did the solution. It's a fine solution. If I do link them, nuclear button, whatever. Here we have, now there's not much color there. We'd have to raise the color saturation, but it is properly balanced. That's the point of this. So I actually had the problem myself. I had a problem with this data right here. This is an image of a particular galaxy that I discovered star streams around, actually. This is the color data, which doesn't show the star streams very well. They're there, but not very well. But you can see it's a beautiful spiral galaxy. And in exactly the same thing will happen. If I try to do the automatic setting here, and we do this, oh, wait a second. I have to tell it to use my coordinates, not, let me pause that. It has to grab the information from the image there. That wouldn't work out. Let's see, 5692. There we go. So now I should be able to do this. I just want to demonstrate. I'm demonstrating on another galaxy. You might think, well, what's going on? I mean, is there a relationship between these galaxies, for example, that for some reason in this catalog, this APASS catalog, APASS 10, what's going on here? So here it is. It's exactly the same kind of error. It's not able to do the photometry. So once again, you wonder what it is about these images that it's having so much problem with. This is what it looks like when I force it to be APASS 9. Again, on my galaxy, although there aren't that many stars, it has stars. It can make the measurement and it can do the color balance just like what we want. So, is there a relationship somehow between these galaxies? And the answer is yes, there is. Now, what I've heard occasionally people say is that the coverage of the APASS 10 version is not very good in the north. And people often say it's in the northern part of the sky in terms of geometry, like declination. I actually think it's not declination. I actually think it's the north galactic latitudes, which happens to be near the northern part of the sky up there near the Big Dipper and Corona. Coma Berenices is the true north galactic pole direction. And that's where a lot of these problems are in that part of the sky. It is towards the north. But there aren't as many stars, and some of the coverage of these catalogs are incomplete. Now, there is yet a new version that should be released of the APASS catalog, APASS 11, which hopefully takes care of all of these problems. One of the things that I think would be best, though, in the meantime, is that maybe one of the developers of PixInsight could concatenate, well, the word's not concatenate, should put together both catalogs, and where one is not represented in the other, then you put in both catalog answers so it fills in more of the areas where they're not covered. Now, that explains everything. You might wonder, well, why don't I just use APASS 9 all the time? Well, because its coverage is not complete either. There are other pieces of sky that APASS 9 is not going to be complete with, and you'll get the same kind of problem. So what do? Well, what you want to do is know that that is the problem, that there just aren't any stars to use. And this is going to apply in the future as well. Even when you get the fancy APASS 11, you want to know, are there actual stars in the catalog or not? We can figure that out. And this is what makes these tutorials different than what you'll generally find. Let's investigate how to do that. One of the cool tools in PixInsight is a script. Under Render, you'll find that there is a script that's called Catalog Star Generator. We can actually show the stars that are in a catalog. We can literally see if there are stars there or not. Don't you agree that that would be diagnostic? Doesn't that actually answer the problem? So if you see a problem like this, then one of the recourses that we have is we can use other tools in PixInsight to help us solve this particular answer, or find the answer to this particular problem. Now, there's nothing in PixInsight that tells you, hey, if you're getting this error in PCC, why don't you go look in the catalog using the script that's called Catalog Star Generator and just see if there are any stars there. No, that's not how it works in PixInsight. In PixInsight, you have all of these tools, and you want to know, if you have a problem, use some other tool that might be diagnostic, that might tell you something about what's going on. So I'm going to show you this gentleman's, the region around this gentleman's image here of M101, and we can do the same thing for the other one, and we can look at the catalog stars. But I'm going to take a much wider field of view so you can see where all the holes are. Here's what it looks like. So what we're going to do is we're going to use the script and set it up to help us see where all of this coverage, these holes, are located. It's under Render. You'll find the Catalog Star Generator. And this is what's going to, I'm going to reset this here. This is what's going to allow us to figure everything out of what is really going on here. So I don't mind that it uses the active image geometry at all, but I do want to specify, I'm going to copy these are the coordinates from this image. So what I'm about to generate will be centered on M101. But what I want to do is I want it to show me all the catalog stars, but in a much larger field of view. So this number here, 0.5 arc seconds per pixel, that's his plate scale. And so if I did it for this image size, it's going to give us an image of exactly the same size that we see here. But I want a field of view that's many degrees across. I want to show you the whole region and where all of these all these little holes in coverage are located. So I'm going to put in, I don't know, I'm going to guess here, a number, 20 arc seconds per pixel. That should give us an image that is many degrees in extent. Then we need to specify the one we're going to look at first is the APASS 10, because I want to show you the problems. Then we'll look at APASS 9, and you can see how there isn't as much of a problem here as there is with APASS 10. And let's use lots of stars. So I'll put 20 magnitude should be fine. That should be a lot of stars. And I think that's it. If we press go here, it is going to generate an image. And let's make sure that it found, yeah. So it says it's painting here 146,000 stars. That's going to take a moment for it to do. So I will be back once it's done painting all of these stars, and we can see where the holes are. And here's the result. Now I'm going to go ahead and name this. This is going to be APASS 10 result, I guess. Now it doesn't look very impressive yet, and I want to make the great reveal in a moment, but if you don't mind, let's go ahead and do, while we kind of know what we're doing here, let's just do APASS 9 as well, so we can see the difference in catalogs, which I think is also going to be something great to be able to see. So catalog start generator, all of that is set. The only thing I'm going to change here is the catalog. See, now I've got 9 instead of 10, but everything else will be exactly the same. Should once again find a lot of stars, although it should be a different number of stars, I assume. Yes, it is. So I'll give it a moment to paint all of these stars. Okay, so here's the result of APASS 9. All right, so here is the great reveal. Check it out. Now it generated stars and it tried to make them, literally as real stars, which is why the render is so cool. And you can see that there are patches here, but let's do an auto stretch on this image. Look at that. Isn't that crazy? This is 10. You can see that there are holes. You know that this field is centered on M101, so somewhere right here is where there is obviously a problem. And I'll demonstrate that in a moment, but let's now compare to APASS 9. Up above here, APASS 9 has fewer holes in it. Now what might be interesting to see is where those holes overlap. Those regions, actually they don't really overlap very much. Yeah. The combination of the two seems to do the job. For example, one we have no coverage here, but in the other we have no coverage beside it. Together, they fully cover that area. So that's what's interesting. One of these two may not do it on its own, but the combination of the two sure looks like it has pretty good coverage. I'll just shade this for a moment. Let me show you the last little quick, cool thing that you can do. You can make your own coverage maps. So because this is literally, it is a field that has the coordinates because we are rendering the catalog itself. That means that annotate automatically is going to work here. Let's use the annotate, it's another rendering script, to show us what's going on in this image. So beforehand, I just increased the label sizes here so that it'll be a little bit larger and it'll be easier to read. So here is the annotated version of this field of view. And if we overlay them and kind of display them like this, you can see that where there could be problems. Now, NGC 5474, that is the blue circle right here. That's M101. I think it didn't print M101 because there's too much text. It's colliding with it with one another here. But that is the galaxy there. You'll also notice in this field is M51. Super, super famous galaxy. And guess what? There are problems in coverage for that one as well. Let me show you what I mean. What you can do is take this image here and let's adjust it. Let's make it an actual, this currently is a linear image, but we could zoom in here and adjust the STF so that it looks a little grayer, and that will make it easier to do what I want to show you. So I'm going to make it a little grayer like that and permanently stretch this with histogram transformation. So we're going to take the STF here, put it here, permanently stretch it like this. Now, what we can do is blend these two images together in the following way. We can just use pixel math. So in pixel math, I better give this a better name. I'll just call this annotated. Let's do, why don't we do 0.5 times APASS 10 plus, and we'll do, what did I call it, annotated? 0.8. 0.8 times annotated. We will make this a new image, and this will create for us what is basically a coverage map. This means I misspelled something. Let's see, what did I misspell? Annotated. Annotated. It's because I didn't spell... No, I spelled that right. Oh, it's the APASS 110. That's the problem. Let's try that again. And there we have it. This is now a true coverage map. You can literally see whether your field of view is going to have a problem or not. You can see clearly why this gentleman, when he was looking at M101, he had a problem because he couldn't find any photometry stars. Now that error, as I said, it's not a great error. I think what that error should have said is, look, we don't see any stars within the APASS catalog at this location. Something along those lines. So that is literally what is going on here. And we should kind of scroll down to M51, such a popular object. Let's see. People that, depending upon your field of view, it's right at the edge there between APASS 9 and 10. As you saw in APASS 9, there's a problem right on this edge where we see M51. So really, you might have to choose 9 or 10 for M51, depending upon your field of view, your centering, all kinds of things. So I hope that this is a cool lesson you can take away. Not only the solution to this particular problem, which may seem arcane until you have it, until you are on an area which has one of these little holes in coverage. And then you'll know that this is the correct thing to do. But more important than that, there are all kinds of reasons why you might want to use, for example, the star generator to render these stars. It will help you, and sometimes, and I've demonstrated this in other videos at Atom Block Studios, that for alignment purposes, it might prove helpful. And it might prove helpful just to be able to do this for reasons that I can't even predict. That's what sets apart tutorials that I make and tutorials that are available at Atom Block Studios. I hope you enjoyed this lesson. I hope there was something you'll take away from this. I just found it truly remarkable to be able to actually see the catalog and to see the coverage. And if you haven't seen this before, well, now you know what's going on, and you'll understand better what is being communicated to you within the program. Thanks for joining me. Remember, please subscribe to this channel if you'd like to see more of this content. I don't do this, I don't make YouTube videos because I'll ever make any money on it. I just don't have the kind of numbers of people. The only reason why I do this is to make this information more generally known, especially with things that I think are commonly a problem that people have, and a mysterious one at that. This is a perfect example of the type. If you'd like to see more content like this, please subscribe and give me some comments below. Let me know what you thought of the video and other things that you might want to see. Thank you.